Hi, I'm Celine and welcome to my automatic object counter video presentation. In this video, I am going to show the automatic counting circuit prototype where the circuit starts counting when the input button is pressed. This shows the schematic diagram of the design circuit. Moving on is the setup and hardware prototype of my automatic object counting device. A 12 volts power block is used to supply input voltage to the 5 volts LM741 voltage regulator, where it will then create a stable 5 volts output to power up this circuit. This 5 volt supply voltage helps prevent damage to the components and ensures their safety operation. The main sensor is a tag switch which serves as the trigger for initiating the counting process. Upon pressing the button, the circuit implements debouncing and threshold adjustment mechanisms, utilizing an op-amp to ensure precise and accurate object detection. After the adjustments, the op-amp generates a clock signal serving as a timing mechanism for the counting operations. The 4026 Johnson decay counter is designed to count from 0 to 9 and reset back to 0, which provides the basic counting functionality. The carryout pin of the first counter is connected to the clock pin of the second counter. The carryout signal completes one full cycle every 10 clock input cycles. When the first decay counter reaches the maximum count of 9 and resets back to 0, a carryout signal will be generated and forwarded to the second Johnson decay counter as the clock input. It then triggers the second counter to increment by 1, enabling the circuit to count from 0 to 99. The 7-segment display is connected to the Johnson decay counter and visually represents the counted value. By switching segments in response to the positive rising edge of the clock pulse, the display shows the corresponding digit. In this demonstration video, the input button will be pressed manually to start the counting process. When the switch is not pressed, the inverting pin, pin 2, is connected to the 5 volts power supply, which is active high. When the button is pressed, the inverting pin, pin 2, is shot to the ground, hence it will switch from active high to low, where the output signal produced is the opposite polarity of the input signal. The non-inverting pin, pin 3, is connected to an ideal reference voltage of approximately 2.5 volts. The output signal of the op-amp is fed to pin 3 through a 10k ohm resistor to ensure positive feedback. To reset the automatic object counter, a high reset signal is required. The master reset pins, pin 15 of both Johnson decay counters are connected to a tag switch which functions as a reset button. This marks the end of my video presentation. Thank you for watching.